I'm Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about digital communication. In this particular slide, I'm going to explain about the quantization. Quantization is nothing but the method of sampling chooses a few points on the analog signal, and these points are joined to round off value to a near stabilized value. Such a process is called as a quantization. It is nothing but the round off value. The analog to digital converters perform this type of function to create a series of digital values out of the given analog signal. The following figure here represents an analog signal. This signal to get converted into digital signal has to undergo sampling and quantizing. Quantizing an analog signal, where the quantizing of an analog signal is done by discreting the signal with a number of quantization levels. Quantization is representing the sampled values of the amplitude by a finite set of levels, which means converting a continuous amplitude sample into a discrete time signal. The following figure shows how an analog signal gets quantized. The blue line here represents an analog signal, while the brown line represents the quantized signal. So both sampling and quantization results in the loss of information. The quality of a quantizer output depends upon the number of quantization levels used. The discrete amplitudes of the quantized output are called as the representation levels or the reconstruction levels. The spacing between the two adjacent representation level is called a quantum or a step size. Here this figure shows the resultant quantized signal, which is the digital form for the given analog signal. This is also called as the staircase waveform in accordance with its shape. There are two types of quantization. One is a uniform quantization, another one is non-uniform quantization. In uniform quantization, the quantization levels are uniformly spaced, where the type of quantization in which the quantization levels are unequal and mostly the relation between them is logarithmic, which is called as a non-uniform quantization. There are two types of uniform quantization. One is mid-rise type and another one is mid-read type. This is the representation of a mid-rise type, and another one is a mid-read type, where here the quantization levels are equal, but the only difference is the axis difference is shown here. The mid-rise type is so-called because the origin lies in the middle of a rising part of the staircase. So the quantization level in this type are even in number. Where mid-read type, it is called where the origin lies in the middle of a tread of the staircase like graph. Here the quantization levels are in odd number. So if it is odd number, we'll call it as a mid-read type. If it is an even number, we call it as a mid-ride type. Both the mid-ride and the mid-rise type of uniform quantizer are symmetrical in the origin. Quantization error. It is nothing but the processing of the system which results in an error. It is nothing but the difference between the values between the input and the output. So the difference between an input value and its quantized value is called as a quantization error. The quantizer is a logarithmic function that performs quantization. An analog to digital converter works as a quantizer. The following figure illustrates an example for a quantization error, which indicates the difference between the original signal and the quantized signal. Quantization noise. It is nothing but the signals will be changing continuously, where the regularity is not found in that errors. Such errors create a wideband noise is called as a quantization error. So in that error, that noise is called as a quantization noise, where compounding is nothing but it is a combination of a compressing and expanding, which means it does both compounding and it does both compressing and the expanding. So the compounding are of two types, ALA and next one is a Mueller compounding. ALA compounding is nothing but uniform quantization is achieved here at A equal to 1, where the characteristics curve is linear and no compression is done. Where ALA has a mid-rise at the origin, hence it contains the non-zero value. ALA compounding was used for pulse code modulation of telephone systems. Mueller compounding. Here, the uniform quantization is achieved at mu is equal to 0, where the characteristics curve is linear and no compression is done. Mueller has mid-read at origin, hence it contains a 0 value. Mueller compounding here is used for a speech and the music signals. So these are the assessment questions. Define mid-read type, compounding, quantization area, step size, and uniform and the non-uniform quantization. Thank you.